Hi, scholars, and welcome to Count on Us. I am glad you could join us today. This show will help you become a successful mathematician by assisting you with understanding and making sense of word problems along with other mathematical concepts. You are going to learn so much from watching this show. I'm excited. Are you excited? Let's get started.
4, 3, 2, 1.
Welcome to Count on Us, Reasoning and Problem Solving, Math 6 edition. My name is Coach Lewis, and I will be assisting you with becoming a successful mathematician. Today we will be looking at Standard 6, NS7. Your goal for today is, I can explain how to use the number line to compare integers. Now let's get started. Our problem for today has two parts. Part A reads, plot the location of -2 and -9 on the number line. Let's take a look at the number line. In the middle is 0. To the left of 0 is -10, and to the right of 0 is +10. This means that to the left of 0 we have negative numbers, and to the right of 0 we have positive numbers. Now, since -2 and -9 are both negative numbers, their locations on the number line will be to the left of 0. So let's plot -2. -2 is 2 units left of 0. Now let's plot -9. -9 is 9 units to the left of 0. Wow, we have satisfied part A. Now let's look at part B. Part B says, use mathematic symbols to write an inequality that compares -2 and -9. Explain how the number line can be used to show that your inequality is correct. Let's look at what this is asking us to do. I'm going to underline some important words that will help me. So, we're going to write an inequality. To determine which inequality symbol to use, we need to think about which number is greater, -2 or -9. Which number do you think is greater? Excellent. -2 is greater than -9, so we will use the greater than symbol. Now the next part of this problem is to explain how the number line shows that the inequality is correct. Well, we know that the number that's closest to 0 is going to be the larger number, and -2 is closer to 0. Therefore, it is the larger number. Our second problem for today deals with temperatures. Let's read the problem together. Are you ready? Let's go. The lowest temperature ever recorded on Earth was -89 degrees Celsius in Antarctica. The average temperature on Mars is about -65 degrees Celsius. Which is warmer, the coldest temperature on Earth or the average temperature on Mars? Explain. Write an inequality that matches your answer. There are two things we need to do in order to completely answer our problem. First, we need to answer the question, which is warmer, the coldest temperature on Earth or the average temperature on Mars, and we have to explain. Well, thinking about negative numbers, I know that the number that will be closest to 0 on a number line is the largest. And if I relate this to temperatures on a thermometer, the negative temperature that is closest to 0 will be the warmer temperature. Remember, a thermometer is an example of a vertical number line. Now, of course, we know that when the temperatures are above 0, those represent warmer temperatures because the number is positive. And when the temperature is below 0, those temperatures are colder because the numbers are negative. Okay. So where would we plot negative 89 and negative 65 on a number line? Do you know? That's it. Negative 65 is between negative 60 and negative 70. And negative 89 is very close to negative 90 on the number line. So which number is closer to 0? Based on our number line, negative 65 is closer, which means that the average temperature on Mars is warmer. Now let's write an inequality to match our answer. That's the second thing that we have to do. Okay, now what symbol would I have to put? Negative 89, I know that that number is smaller than negative 65. Okay, so then I will put a less than symbol because negative 89 is less than negative 65. Or I can write it another way and put the greater than symbol. Negative 65 is greater than negative 89. In our previous problem, we looked at lowest recorded and average temperature on Earth and Mars. Now let's extend that problem a little further. The diagram shows the planets of our solar system and their mean temperatures in degrees Celsius. Carrie says the mean temperature on Jupiter is greater than the mean temperature on Mars because negative 110 is the larger number. Explain why Carrie's reasoning is incorrect. Remember what we discussed about number lines? The negative number that is closer to 0 will be the larger number. So looking at the mean temperature on Mars, which is negative 65, and Jupiter, which is negative 110, let's decide which one is closer to 0. That's right, negative 65 is closer to 0. Carrie thought that Jupiter's temperature is greater because he must have just looked at the number itself, 110, without considering the negative sign in front of it. Because actually, negative 110 is less than negative 65. And we can see that on our number line. Even when we put the numbers in order from coldest to warmest, we still see that Mars is close to 0 and the positive numbers. Let's put them in order. We have Neptune, which is negative 200. Now we're putting these numbers in order from coldest to warmest. So our coldest temperature is Neptune, negative 200. Then Uranus is negative 195. Saturn is negative 140. Jupiter is negative 110. Mars is negative 65. Earth is 15. Now we're getting into the positive numbers. Mercury is 167. And Venus is 464. So we just put the numbers in order from coldest to warmest. This further shows Carrie's reasoning was incorrect because Mars, which is negative 65, is still closer to Earth, which is the positive numbers, which means it is closer to 0. Let's revisit our goal for today. Our goal was, I can explain how to use the number line to compare integers. How did we accomplish this? You said it. We started out comparing -2 and -9. Then we compared temperatures on Earth, Mars, and Jupiter. We learned today that a number line can assist us with comparing numbers because the closer a negative number is to 0, the larger the number. Congratulations! That's our show for 6th grade today. 7th grade will be coming up next, so stay tuned. And remember, you can always count on us.
Hi, welcome back to Count on Us. I'm Coach Hubbard, and today we're going to look at an activity entitled Tossing Beanbags. We're going outside today to do math. Before we get started, I would like you to remember, by the end of today's lesson, you'll be able to calculate the total area of 3 rectangles. Are you ready? Let's go outside.
If you're on Team A and your beanbag lands in the purple rectangle, you score a point for Team A. If you toss your beanbag and it lands in the pink rectangle, you score a point for Team B. If you toss your beanbag and it lands in the yellow rectangle, you can score a point for Team A or Team B.
Remember, if your beanbag lands in the purple rectangle, you score a point for Team A. If it lands in the pink rectangle, you score a point for Team B. And if your beanbag lands in the outlined yellow rectangle, you can score a point for either Team A or Team B.
Let's look at the given information from the problem. The area of the purple rectangle A is 10.5 square meters. The area of the pink rectangle B is 8 4/10 square meters. And the area that overlaps rectangle A and B is 3/25 the area of rectangle A. That's the yellow rectangle.
So how do you suppose we're going to find the total area in square meters that I taped off in the parking lot? Let's look closely at the math. We're going to add the area of rectangle A with the area of rectangle B. Then we're going to subtract 3/25 the area of rectangle A. Go ahead and grab some paper, a pencil, and a calculator if you have one. Are you back? All right. We're going to write the expression that represents the total area of rectangle A, B, and the yellow rectangle that's inside of rectangle A. Are you ready? We're going to add the area of rectangle A, 10.5, plus the area of rectangle B, 8 4/10. And we're going to subtract 3/25 the area of rectangle A to represent the yellow rectangle. If you notice, I have to multiply my fractions. Before I multiply my fractions, I notice 25 is divisible by 5, and so is 10.5. If I reduce that numerator and denominator by 5, I rewrote my fractions as 3 over 5 times 2 and 1/10 over 1. Now I'm going to multiply those fractions together, and the product is 6 3/10 over 5. I'm going to reduce the fraction to a decimal by dividing. The quotient is 1 26/100. Now I can add and subtract my decimals. They're all in the same format. I'm going to add 10½ plus 8 4/10 minus 1 26/100. So what's the total area? The total area I marked off with my tape is 17 6400 square meters. Let's recap today's lesson. First, you need to reduce the fraction by a common factor. Number 2, you need to multiply the fractions to find the product. Number 3, convert the fraction into a decimal. Number 4, we're going to add the areas of the two rectangles A and B and subtract the overlapping area so it is not counted twice.
Welcome back, everyone, to Count on Us. I know you just saw me, right? I get it. With 7th graders, I just had to sneak this lesson in. Did you know that I'm a scientist as well as a mathematician? Today I'm going to take you into my laboratory, and we're going to calculate total mass of that chemical sitting on my table. So by the end of today's lesson, you're going to be able to calculate 3/10 of the chemical, and you're going to calculate the total mass. Are you ready? All right, let's begin. Today I removed a sample of 39 1/10 grams of a chemical from the container on my science table. There's my sample. It's in my beaker. The sample was 5 3/4 grams less than 3/10 the total mass of the chemical in the container. So I wrote this equation, but I need to solve for 3/10 the total mass. So I recognize that I've got a negative 5 3/4. So I'm going to use the additive inverse. And I recognize, okay, now I have 0 pairs. So I can cancel out negative 5 3/4 plus positive 5 3/4. Oh, that sum is 0. Now I'm going to take my sample, which is 39 1/10 grams, and I'm going to add it to 5 3/4 grams of the chemical. I don't like working with those fractions, so I'm going to convert 3/4 to 75/100. Now I have the sample and the 5 3/4 grams in the same format, so I can add my decimals. I just calculated 3/10 the total mass of the chemical to be 44 85/100 grams of the chemical. Represents 3/10 the total mass of the chemical in the container. So let's continue on. So let's find the total mass of the chemical that I started with. And that's before I remove the sample of 39 1/10 grams. So I have my equation, and I'm going to use the multiplicative inverse to cancel out my 3/10. If you notice, I multiplied by the reciprocal on both sides of the equation to keep the equation balanced. And I've isolated that total mass because that's what I'm looking for. I still have fractions on the left side of my equation. So I'm going to try to reduce those fractions by a common factor. I decided 3 divided by 3, okay, that'll give me 1. And I noticed that 44 85/100 is divisible by 3. So I'm going to multiply 10 times 14 95/100. Oh, what do you know? The total mass of the chemical is equal to 149.5 grams. Bad. I wonder if there's another way of solving this problem. Okay, I start with my equation. Okay, I remember. This time I'm going to convert that fraction 3/10 to a decimal. Now I'm going to divide by 3/10 on both sides of my equation. I still have the same total mass, 149.5 grams. Let's review today's lesson. First, we highlighted the important quantities in the situation. Then, we organized the quantities to write an equation to represent the sample. Originally, the sample was 5 3/4 less, so we used the additive inverse property to add
5 3/4 grams with the sample. To find the equivalence of 3/10 the total mass that was in the container. Now remember, that's the additive inverse. So with this equation, we were able to substitute 39 1/10 for the sample. We converted our fraction by dividing numerator divided by denominator. This gave us a product of 3/10 the total mass. Then we used the multiplicative inverse property to solve for the actual total mass. We simplified fractions using a common factor. Finally, we found the total mass for the chemical before the sample was removed. Not bad.
That's it for 7th grade today. The next segment will be for our 8th grade students. See you next time. Remember, you can always count on us.
Welcome back to another Count on Us with Partnering with Parents. I'm Coach Brenner, and today what we're going to do is we're going to talk about some things you can do at home to make sure that your students are prepared, whether they are continuing at home distance learning or if they're beginning to start in-person learning in the classroom. Some of these things just to make it easier on you as the parent when these changes are taking place, and also these changes for students since it's been almost a year or over a year since students have been back in the buildings. So throughout this episode, we're going to be talking about some of these different things that you can do at home to make sure that your child is as ready and prepared as possible when they go back in the buildings, or if they're continuing with distance learning at home. The resources that all students have, whether they're at home or they are inside the classroom, and they've been using this year as well, are some different resources through Clever. Now, in order for your child to sign in through Clever, they just have to sign in with their ID and their password, just as they would log on to their Chromebook or their email. Just as your students have been using possibly anything from Google Classroom this year, or to anything else that your child's teacher has asked them to sign on to. So in Clever, there's a bunch of different resources that are paid for by the county. One of them is Dreambox. Hopefully, if your schools have them and have distributed all the passwords and IDs, your children have been getting onto Dreambox. Dreambox is something that helps your child with on-grade level math standards to make sure they're staying where they need to within their own grade level. It also is challenging, and it's kind of just fun in some games. There's some other different apps down here. We know our Big Ideas that connects to some different textbooks. We're not necessarily using that right now, but for the older students that are those 6th, 7th, and 8th graders that have Big Ideas Learning, they can use that. Now, to K through 5, they're in Envision, so don't worry too much about that. IXL, that's another site that your students can practice different math problems. It's connected to standards as well. And these are just some things that your students can do at home. Now, one of the main things that students have been using this year in K through 5 for their online resources and tools is Braining Camp. Okay, and we're going to take a look at Braining Camp just to show you some of the different online tools that your students can use when solving math problems. Braining Camp is one of the apps that has been embedded into most of the activities that your students have been doing online this school year during distance learning. It's something that's going to be embedded in the activities and tasks that your students are doing the rest of the school year as well. Now, K through 2, we know that the majorities these are still going to be useful to them. And we know 3 through 5, some of the other ones such as algebra tiles, coordinate board. But these are all different resources for students to use. Now, one of the main things to build that fluency and understanding for students is using base 10 blocks. So we'll just take a look at it. We'll click on it. With the base 10 blocks, say students are adding a 3-digit number. Let's say the number is going to be 243 plus 325. We can put that text right there, and we know that that is something that they're adding. We literally can make 243, 1, 2, 3, 4, and then here, if we wanted to do 325 down here, we can move these down. And the cool thing with this is really giving your students an opportunity to kind of just check their work, because down here at the bottom, it'll tell the total. Now, if they click that I, it'll take it away. But if they really want to just check to see if they did their work right, say they're doing their work in a notebook, or they're doing their work in Pear Deck. This is just an option for them to come and check their work to make sure that it is correct. So this is how, and there's a lot of different ways that they can use this. There's decimals. So those 4th and 5th graders with tenths and hundredths, they can use that as well. So this is one of those concrete models that really help support student understanding in terms of math. Now, back here, for the younger students, we have the tiles, there's Cuisenaire rods, geoboards, hundreds board. There's just a lot of different things that students can use in order to help support their learning. So as a parent, check some of these out. Ask your students to show them, your child to show you how to utilize these so that you can get familiar with them as well. And if you have a little bit of time, you can log in through Clever with your student ID, your student's ID, and you can actually go through and check some of these out. So one of the organizational strategies that we've been working with students actually over the last couple years is the 3-read protocol. So it's important for you as a parent to understand how your child should be using this when they're solving math word problems. This is an organizational tool for students to kind of just get the problem started. So in a 3-read protocol, if you hear a teacher talking about this or your child mentioning this, this is how it's set up. So with a 3-read, the first read, students reading the problem. So what's going on in the actual problem? So they're just reading the problem as it is. The second read, what are the quantities? So what are the units? So they start pulling the units out of that particular problem. And then when they read the problem the third time, they actually come up with some math questions they can ask based on the information. Now, when teachers... All right, so let's look at this example. It's titled Books, and we're doing that 3-read. So the first read, we're going to read through the information and break down. So at first, we have Miss Smith's class library has 423 books. 50 books were borrowed by students. Okay, so we know that this is math, and we're doing something. We're going to be either adding on or taking away. So we're reading through to understand the first 2 sentences. Notice there's no question yet. Second, we'll pull out the quantities and the units. The quantities are the numbers. The units are what's connected to those numbers. So the quantity, 423, the units are books. In the second sentence, 50 books, the 50 are the quantities and the books are the units. So third read, we'll read through it and we'll pick possibly a question that we could answer. Miss Smith's class library had 423 books. 50 books were borrowed by students. So a possible question could be, how many books are left if the 50 books are borrowed? So let's see what a possible question could be. How many books were left in the classroom library? So being able to come up with that question allows the students to realize what they might have to do when solving for the problem. Thank you guys for tuning in to another episode of Partnering with Parents. Today, we looked at some of those online resources that your child is using at home or in school. These are some different ways that they're learning how to do math on their computer. This is also some different ways that you can help support them going through some of those online tools, learning how to use the base 10 blocks or color tiles or the geoboards. Those are just some things that you can do. We know you don't have a lot of free time, but in your free time, that your child can show you how to use some of these tools. We also went through a strategy that your child's using in their math classroom, which is the 3-read protocol. In these 3-read protocols, students are breaking down word problems. It's important for students to show their comprehension in terms of what the question's asking them, to grasp the understanding so that when they're solving it, they know exactly what they need to do when getting to that final answer. Thanks for tuning in for another episode. We look to see you guys in the future. Partnering with Parents episodes. I'm Coach Brenner. You guys have a great day.
4, 3, 2, 1.